Video, we are going to look at a story problem to use the law of cosines and the law of sines to solve it. So looking at this, we have a wire 5.3 meters long is attached to the top of a flagpole that leans left in a strong wind. And where we're from, you know that our winds can get pretty strong. The wires anchor to the ground 1.2 meters to the right of the pole. The wire forms a 68-degree angle with the ground. What angle does the wire form the top of the flagpole? Round to the nearest degree. All right, so looking at this, what we do see is that we have, I'm going to call this A. Let me get a different color so we can see that a little bit better. I'm going to call this A. Still can't see that. Sorry, guys. A. I'm going to call this one B. And this is C. So this is little A, little B, and this is C. If I were to just jump straight into this and use the law of sines, because this is the angle that I want to know, at what angle does the wire form from the top? So I want to know this angle here. I want to know angle A. And if I were to jump straight into this, well, I have sine of B divided by B equals sine of A divided by A. Little a. Or I could say this is equal to sine of C divided by little c. Well, here's my problem here. I know the C here. The little c is going to be 5.3. And I know A, which is 1.2. But I don't know, and I know this B is 68. But what I don't know is this A, nor do know the C, which would give us two variables that we need to solve for each of these. And since there's no easy way to solve that, I'm going to go straight into the law of cosines, so that I can kind of find the other legs. I can find the other angles. All right. So I think what I'm going to do is, I know these two, I'm going to find the B. So B squared equals A squared plus C squared minus 2A times C cosine B, which is perfect because we know the angle of cosine B. All right, so B squared is still going to be B squared. We have no information for that. A squared is going to come out to 1.44. C squared, which is 5.3 squared, is going to be 28.09. And then this is going to be minus 2 times 1.2 times 5.3, which comes out to 12.72 cosine 68. All right, so now looking at this, B squared is going to be roughly, and I should put that at the very beginning, or I don't do that since I'm rounding, 2.477 meters. All right, meters squared, because again, we're doing B squared, take the square root, and I get my B high here as being roughly 4.98 meters. So B is 4.98 meters. All right, so why did we do all this work? Why did we do the sun? Well, this gives us a side and an angle. So all we have to do is find angle A. So I'm going to use the law of sines now. So I'm going to do sine A, which is the one we're going to try to find, divided by little a, equals sine B divided by little b. Well, using substitution, sine A is what, again, we're trying to find, but A on itself is 1.2 meters. And this is going to equal sine B, and B is 68 degrees, so sine of 68 degrees divided by 4.98. right, multiplied by 1.2, we get sine A equals 1.2 divided by 4.98 sine 68. Take the inverse to undo the signs. This piece is put into the calculator. And so we get the angle A is equal to, again, calculator, so roughly equal to 12.9 degrees, which means that this right here, this angle right here is 12.9 degrees. So the angle formed by the wire and the flagpole is, and they want us to round to the nearest degree, so the angle between the wire and the flagpole is 13 degrees. All right, so this is the use of both the law of cosines and the law of sines to solve a single problem. All right, guys, so this is the end of this video. If you have any questions or comments, always feel free to ask, and I will catch you in the next video.